Hi, we're back with Professor Solis and Strategies for Success. So we're going to talk about simplifying algebraic expressions. So let's get that up here. Simplifying algebraic expressions. And I'm hoping we remember our GMDOS. I'll just put it right here. I hope we remember what all the letters stand for, but real quick, G is the grouping symbols, E is for exponents, M is for multiplication, D is for division, A is for addition, S subtraction. Remember, multiplication, division rules go together, addition, subtraction rules go together, and the grouping symbols and exponents, those are interchangeable. So let's talk about expressions. So we're talking about algebraic expressions. A lot of times we think as students we will solve everything. Well, we don't. We simplify. So simplify means we reduce and try to get our math into as small as we can make it. So reduce is another way of maybe saying simplify. So let's say we want to simplify 3x plus 8x plus 9. So in case we forgot, we have some vocabulary that maybe we might want to add in our notebooks. If we remember the term like terms means they have definition would be the same variable and, or I'll put plus, the same power, or just constants. And constants is a fancy way of saying just numbers, okay? So when we look at this expression right here that I boxed, what looks like our like term? We have a 3x and 8x. This x and this x both have a power of 1. Even though we don't see it, it's an invisible 1. We call those like terms. So we can put those together with the plus sign. 3 and 8 would be 11, and we keep that base of x. 9, there's nothing that's like 9, so we just bring that 9 down, and we're able to combine the like terms, 11x plus 9. This would be what we call a simplified algebraic expression. Now, some of you are like, oh, so we just add those. Well, let's take a little step to the side here and make sure we didn't forget our sign rules. That's real important when we start talking about expressions and then equations later. So if we remember, if we have a positive number plus another positive number, we're going to add those together, and I'm going to put the add right below here, and we're going to end up with a positive value. Then if we have a negative number plus a negative number, we're still going to add, but we're going to keep the sign with the negative. If we have alternate signs, a negative number and a positive, this is now where we subtract, and the rule is we keep the sign of the larger number. Larger, and I don't always write out the word number. Sometimes I use the number symbol. So that might be something you remember that Professor Solis does, okay? So if we go back over here, we have a positive 3, a positive 8. So we add those, plus and plus we add. That's how we got the 11. So let's do another quick one. Let's say negative 10x plus 5x minus 4. So if we're simplifying same directions, these are our like terms. X, same power. But I have a negative and a positive 5. Negative, positive 5, opposite signs. Keep the sign of the larger number, and we subtract. 10 minus 5, that would be 5. Remember to keep the sign of the larger. Keep the variable. And this would be simplifying an algebraic expression. So in case we forgot our sign rules, we want to make sure we get those down. In case we forgot what like terms were. And numbers. The only way I would add this 4, negative 4, I would need another number over here, and then those would be like. So that's what we mean by constants, just in case we forgot. Okay, we will see you at the next one. Have a good one.